Hey guys, today we'll be solving LeetCode number 46, Permutations. This is a medium problem on LeetCode. And this is also the first ever backtracking question that I will cover on this channel. Now what is permutations itself? To clear that up first, so let's consider this array over here taken from LeetCode example 2, 0 and 1. Permutations essentially just means reordering of the array. So what are the ways we can order this? So we're given 0, 1, right? The original itself is in ordering, and the next ordering that we can do is 1 0, right? Shift the 2. And the formula for permutations is like if you're given 1 2 3, right? Then if you draw out like these small boxes over here, then in the first slot you have 3 choices, right? So you can pick any of the 3. And then in the next one you have 2 choices, and then in the last one you only have 1 choice, so you get 6 total combinations, right? So if you count out the number of elements in the output for example 1, you will see that there's 6 of them, right? And like I said, it's all about just shifting the spot that you go to. So 1 2 3, right? What is the ordering? We can do swap between 2 and 1 and 2 and 1, or swap with 3, so something like 1 3 2, right? But how do we first figure out what to put? Because in some cases we can also not put 1 over there, right? We can put 3 1 2, something like that. So how do we figure that out? The first thing that we should do is, first I'll just draw out this. So let's consider an empty array, right? Let's consider 3 options that we can take. We can take 1, we can take 2, we can take 3, right? Then over here, once we've taken 1, we have 2 choices. We can take 1 2, we can take 1 3, right? Over here, 2, we can take 1, we can take 3. Like this, right? So these are the options that we can have, right? So what have we done? We've picked 1, then we've picked 2 or 3, 1 or 3, or 1 or 2, right? After that, and then I'll just draw out a shorter version of it. So 1 2, then we can pick 1 2 3. This gives us our original. If we pick out 1 2, sorry, 1 3 2, like that, we can do 2 1 3, right? And stuff like that. So we can just keep going. I won't draw out the full example. And what do we do over here as well? We pick some number, right? So all we're doing is we check from our possible combinations, right? That which one have we picked, which one have we not picked, and the ones that we've not picked, we pick them, right? And we essentially pick the next one until we hit some base case, right? Until we hit some base case, our base case being the fact that the permutations themselves won't exceed the length of the original, right? All the permutations, all the orderings will be in the same length as the original. So exceed length of nums, then end, right? That's our base case. By the way, backtracking is all about recursion, so you need to be good with recursion first. And now I'll move on to how we go about storing it in the results. So our end products here will go into the result array, but how do we keep a track of the lists that come before it, right? We use a temporary variable before we make our choice, right? And we also, how do we determine whether we've picked it or not? Well, we also have a boolean array, false, set to the length of numbers, right? And we also have n be the length of numbers, right? Okay, so now the first thing that I'll do, I'll set up a helper function, because we need to do, essentially all we have to do is just do, you can name the function anything. I call it DFS because that is what we're doing, depth first search into the tree. But yeah, why do I call a helper function? Well, it's because it makes things easier, and we also will need it because we need to store the result, right? That we're not doing it in one go. So depth first search over here, that's what I've named it. And what is our base case? Like I said, if the I, by the way, being the index that we are on, so within the permutations 1 2 3, which index are we on, right? And if I is equal to the length now, right, this is our next iteration, then res dot append our temporary, make sure it's a copy, and return. Okay, so that's our base case done. That's not really the main issue. The next tricky part is how do we figure out which one to pick. So 1 2 3 will be set to F F F F, right? Okay, and how do we know when to pick one? So what we can do is when we loop through our picked array, right? If we see that there is a false over here, we will essentially turn this false to true and pick this element to generate a possible combination. So we would add to our temp 1 in this case, right? So the first iteration would be like temp as 1, right? And then we move on with our next index. Okay, then we see that 2 is false, we set that to true, then we add that into our temp, so 1 2, right? I plus 1, do the same, and temp will be 1 2 and 3, like that, right? So that's how we basically did a small dry run of what the implementation of the algorithm is. And like I said, we will keep a track of the index that we're on. And when do we pick? Well, we pick when it's false, so if not picked. Also keep in mind this should be different from the index that you're using as like the indicator of the index. And then we pick it, right? Now, like I said, we will call DFS on the next index, right? And essentially what this will do is this will run this over here, this whole iteration, right? False for 2, false for 3, and it will store it into the array. It will help the base case and it will return, right? After that, it stores this 1 2 3, right, into our DFS, correct? So we did this on our first iteration. So we did this on the first ever I, right? I is equals to 0. We gave 1, it came out to 3 all the way, reached 4, hit the base case, and came back to this state over here, this state. Now what do? Well, we've already considered the combination that we can take from this point onward. So now we will simply remove it from our temporary array, and we will set this to false, so that upon the next iteration, when we are on 2 over here, when we are at 2, and we essentially, when we do temp.append 2, pick 2, and then we will run for 3, right? And then we would do the same, then it would come out to be 2 3 1, and etc etc. So after that we just set it to false. Now just call the helper function with the index, so the first ever index, and then return result. And that's pretty much it. Because by the way, this would, like I said, keep this not to I, keep this as index, right? Something different from I, because this will have to loop for the entire time. So when we do pick 2, right, it will still loop through 1. Essentially it will still consider 1, so it will check okay, 1 was not picked, so we will pick it. So I will do 2, 1, and so on and so forth, right? I will do all of the combinations for you. That's pretty much it.